So an application attack. Application attacks exist usually because, and I'm not going to pick on developers here, but man, it is a love-hate relationship sometimes. Just because, I love the fact that they create applications for us that, drive the business and stuff, but from a security perspective, I just have a heart attack sometimes. Many times they're not the applications they create aren't thoroughly tested for any type of vulnerabilities while they're writing their application, which then obviously leaves many programming flaws that an attacker can take advantage of. Now, the reason why these usually take place is because, first of all, the developer may be under time constraints. He's taking shortcuts to make sure he hits a deadline. He may be adding some features, and sometimes those features create vulnerabilities within the application itself. Also, there may not be enough time to do adequate Q&A. I'm reminded of a very famous case back in 2010 where McAfee released an update to their antivirus solution. And in it, again, they were in a rush to get this out. They didn't have enough time to do a good quality assurance inspection of their update. And as a result, it caused tens of thousands of systems to crash and burn. And the reason why it did that is because the flaw that they had in their DAT file, which was their antivirus file, their database file, it caused their program to give out what they refer to as a false positive, which means it was falsely identifying a file as being a positive virus, and therefore it cleaned it. And that file was the svc host.exe file from Windows system file, which is used everywhere throughout the Windows environment. Many of your applications launch underneath, or system services launch underneath that particular file. So what happened is, once you applied the patch to your systems, and this was typically done through automation, users were greeted with a wonderful blue screen of death, which then resulted in a never-ending loop of system reboots. Now, you may be thinking, wow, that really sucks for a lot of corporate folks, but you have to remember who else uses computers that this could be an issue for. Police departments, hospitals, school systems. Another issue that sometimes comes up is when a developer comes out with an add-on. Typically, security is not really, he's not thinking about security when it comes in with the add-on. In fact, I was working for a software company where they came out with an add-on, forgot to clean up the code, and it created some additional problems once they deployed. Again, that typically comes back to the QA environment. Now, the result of these causes creates buffer overflows or cross-site scripting, which we'll talk about again further in. Also, active content and denial of service and SYN attacks. And finally, SQL injection. All of these different types of attacks are typically thrown at an application server. Sometimes it's a web application server. Sometimes it's just an internal app server. And you're going to hear a lot about these different types of attacks that can be done at the application level. Other type of application attacks that can take place include session hijacking. If I can overload the system, you may be in the middle of a secure session between you and another machine. I'm going to interrupt that session, take it over and kick you off or dump you off, and I'm going to continue on in your session as if I was you. Also, man-in-the-middle attacks are very, very common with application vulnerabilities. And the reason behind this, or the concept behind this, is I'm going to just act as a internal midway point that you're not aware of, the end user's not aware of. You think that you're hitting the actual destination point, but I'm capturing information all along the way, and that's why I refer to it as a man-in-the-middle. Also, directory transversal. Now, this is also known as the .. attack. The goal of this particular attack is to order the application to access a computer file that it's not intended to be accessible. And we're able to do that by basically backtracking, what we refer to as backtracking, or even directory climbing. A visual representation of this might be, let's say that I'm sure some of you guys have seen this before. You've gone to a website and you've clicked somewhere, or you've accidentally gotten into, it looks like a directory structure, but it's being displayed to you on a web interface. And typically at the top, it has a .. and you can click on that. You can actually back up a directory. They meant for you to actually see a website or web page, but instead you're seeing the directory structure. Happens quite a bit on web-based servers. But technically what we do is we actually, since we're into the application, we throw at the application a command such as //////, trying to back up as much as we can. And then we may end that up with the code of /etc/ password. Actually, it's PASSWD. What this does is allows the application, or causes the application, to transverse to the root directory and then actually get into the Unix password file located in the etc password directory. Now, this has been fixed by a lot of some of the newer Unix and Linux systems. The password file doesn't actually contain a hash password. They've actually moved them over to what they refer to it as a shadow file, which can't be read by any user. So it's kind of a, we use it all the time to show off the concept, but it's not always current in the wild. Well, it really does depend, because if somebody has a system that's a little bit older that they haven't fully patched, it still could work very well.